So some things that you should notice as we move on to lesson 2 in unit 2, you should see some similar 3D solids here. Just like we talked about last week with volume of prisms and cylinders, we're still talking about prisms and cylinders. But notice we're going to learn a different concept today. Instead of talking about volume, we're going to talk about surface area, a pretty important concept for what we're doing in unit 2. So just remind yourself a couple things about prisms and cylinders. Remember we said what defines that is the fact that there's going to be two congruent faces opposite of each other. So if I'm looking at a rectangular prism, I might have a rectangle on bottom and a rectangle on top, right? That's what makes it a rectangular prism. This is a cube, but it still maybe qualify even as like a square prism. I have a square on the front and I have a square on the back, and those things are the same. And then of course we said a cylinder could even be, we could get away with calling this a circular prism. We have a circle on a circle, and that distance between those two congruent faces we said was the height. But so still talking about prisms and cylinders, just now going to learn this new concept of surface area. Hopefully we're paying attention and following along, and hopefully your notes look like my notes so you know what you're doing for the next couple days. So the surface area of a solid is simply the sum, it's the sum of the area of its faces. It's not overly complicated, but when I find the surface area of a solid, I want to find the area of every face on that solid, and then I want to add them all up, and it's the area of the surface of the solid. That's where surface area comes from. So an example that we have for you here is like this pizza box. Right, it says the pizza box has the shape of a rectangular prism. What is its surface area? What is the sum of the area of all its faces? So some things that are going to be important here is that we understand how to build these 3D solids and how many faces they have and how do they look and how do they relate to each other. And so one thing that really helps us with surface area is something called a net. And this is something that you should have seen before in previous classes. And darn sure even in just 6th grade you were working a little bit with nets and surface area. It says you can use a net to find the surface area of the pizza box. And a net is simply a 2D representation of a 3D solid. What I like to think about is I take this three-dimensional solid and I unwrap or I unfold or I flatten it. So I take what was a three-dimensional solid right here, which I know has 6 faces, and I lay those faces out flat. Think of it as like when you have a cardboard box and you break that box down and flatten it out. That's what we're doing with these 3D shapes. We're flattening it down and making it two-dimensional. So like I said, I would think to unwrap or unfold the solid. I would think flatten the solid. I'm trying to get all of these faces flattened out so I can have another representation of this. What you hopefully should be able to recognize is how we could get back to where we were. If I folded these sides both up, I folded this side up, I folded this side up, you'd be close to being back to your rectangular prism. Notice this side all the way over here would have to come all the way up to be the top. And so I'd have 4 sides and a top and a bottom, and I'd have those 6 faces that make a rectangular prism. Now, why are we talking about nets and why do we care? Well, because the surface area of any solid is equal to the area of its net. So if I could find the area of the net, I would have the surface area of the solid. Let me give an example of what I mean here when I'm looking at this pizza box. It says draw a net for the pizza box and then find its surface area. When I go to do this, I always try to think of starting with the bottom first. Now notice I didn't say base, but I said start with the bottom. So as I look at this pizza box, I notice what I see here about the bottom. The bottom, apparently, it looks to be a square that is 16 by 16 inches. So when I go to draw this net right out here in the middle, I don't really like that. We better do a little better job of a square than that. I'm going to draw a square that's 16 inches by 16 inches. And that'd be one important piece of information that I would strongly recommend. As you draw your net and as you draw the faces, label the dimensions as well. It's going to be pretty critical that we label the dimensions as well. I start with the bottom, and now I want to unfold this. I want to build this pizza box down. And so then I start to notice these edges that are around the pizza box, right? And I see what kind of continues to happen on this pizza box. Up from the bottom, I have pretty slim rectangles that go around all the sides. Notice they're all 16 inches long, but then I need to recognize, well, how high are they, or how tall are they, or what's that other dimension as I draw this net? So you should notice they're 16 inches by 2 inches. And so again, I want to label that as much as I need to make sure I understand what I'm looking at for those shapes. Now, you might think you're done, but I want you to realize if we folded this pizza box back up, our pizza box would be missing the top. So this isn't going to work for us. This is not a good net for that pizza box. Not only do I have this bottom base right here, but then I need the top that's congruent to it. So nice thing is it doesn't matter where it goes, but you need to draw one more face that's exactly the same as the base that could fold back to be the top of my rectangular prism. So maybe I put it down here. As I folded this all the way back up, now I should be able to see how this net folds back together to be a rectangular prism or a square prism like we see with the pizza box. Now, that's my net. Excellent. I've done that. Now it says find its surface area. Well, what I think we just talked about was the fact that the surface area of a solid is equal to the area of its net. So what I'm going to do is I'm going to look at this net that we've drawn, and I want to find the area of all these faces, and I want to add them up. So one thing I can maybe start with is this square base. Well, we know it's 16 by 16, so I want to find the area of that square base, and I'm going to take 16 times 16. When I take 16 times 16, I should get, if we're doing this right, 16 times 16 is 256. So I know the base here has an area of 256 inches squared. So 256 inches squared there. Ooh, man, having some fun here. 256 inches squared. Now the nice thing is, if I know the base has an area of 256 inches squared, I also know the top has an area of 256 inches squared. Not done, because I need to account for those four thin rectangles that are 16 by 2. So that tells me that each of these, 16 times 2 is 32. Each of these would have an area of 32. To find the surface area, then, what do I need to do? Well, I need to take 256 plus 256 plus 32 times 4, right? I want you to think about that. I have 4 that are 32 for the area. So I can maybe take 32 times 4 and say 256 plus 256 plus 128. So when I add this, 6 plus 6 is 12, plus another 8 is 20. And I carry the 2, and 5 plus 5, and 2 is a 4. And I carry the 1, and then I have 1 and 2 and 2 and 1. And I notice that I have 640. 640 inches squared. And I want you to notice that that's pretty important when we're finding surface area. Surface area is inches squared because it's area. We didn't find the volume. We didn't find anything in cubic units. We were finding area, and so area is always labeled in inches squared. Now, don't get me wrong, we can always get away with drawing a net to find the surface area of any solid, and in fact we're going to talk about this as we get deeper into the different shapes that we might encounter. But one thing that is pretty nice is the way that we see rectangular prisms always tend to exist. Because of the way rectangular prisms are put together, there is a shortcut here. What I want you to think about when you think about a rectangular prism is a rectangular prism always has 3 pairs of congruent faces. 3 pairs of congruent faces. Now, truthfully, it might even have more, like on the last example, but we have a bare minimum of 3 pairs of congruent faces. What I'm saying is, I know that the top and the bottom are always going to be the same. I know that the front and the back are always going to be the same, and I know one side and the other side are always going to be the same. I have 3 pairs of congruent faces. And so what this leads to is a formula for surface area in which I find the area of each of those different faces, one marked with the red X, one marked with the blue X, one marked with the green X. And once I have those areas, if I just double them and add them together, I would be okay. So what I want you to think about is this idea of 2 times the length and the width. Well, that would be 2 times the area of the top and the bottom. Right, so I find the area of the top, and then I double it, and I'd have the area of the top and the bottom. For the height and the width, you're thinking about the sides up there. The height and the width would be the area of the sides, so I'd have both sides here when I double it. And then, of course, the length and the height would be like the front and the back. And so this formula is a way to do kind of a shortcut method to find the surface area of any rectangular prism. I want to be very clear. If you don't understand what I'm talking about right now, this can always work. It will always work to draw a net. So if you can't memorize this formula or understand this formula, don't use the formula. Go ahead and draw a net. But what I would do on this first example here with after knowing the formulas, I do want to talk about this concept of understanding how this works. All I need to do is take each dimension times the other. Each dimension times the other. And I think you'll see what I mean when I'm trying to color code this. And once I've taken each dimension times the other, then I will double them and add them up. So the first one that you see is I was going to take 5 times 15, right? I'm going to take the length times the width. So I'm going to take 5 times 15, but I need you to remember that I need to multiply that by 2. So I have 2 times 5 times 15. Okay, I also need to take 5 times 4. That's the other dimension that I see where I have the length and the height. Okay, so I'm going to take 5 times 4, but I have to take that times 2. Okay, and then the last 2 dimensions that we still haven't multiplied together would be the width and the height. So, okay, now I've got to do 15 times 4, but of course I've got to take that times 2. If I can find each of those using that formula and add them up, I'll have the surface area. Nice thing here is commutative property says I can do these in any order that I want, but I see 2 times 5, which is 10, and 15 times 10 is 150. On the next one, I see 2 times 5 is 10, and 10 times 4 is 40. And then on the last one here, I see 2 times 15, which is 30, plus 40 is 120. And we're going to add all of these up. And so I have 150 plus 40 plus 120, and I should get a total of 310. 310 what? Well, it's surface area. Area is always labeled in units squared, so it's 310 feet squared. Okay, so I do just want to remind you that you can use this formula for the surface area of a rectangular prism. It is absolutely not required, and if you didn't understand what I just did, you could surely have drawn a net of the bottom, the sides, the top, find those areas and add them together. Now, speaking of nets, I think it's really important for triangular prisms that you understand that's the only way I can really do this. There is no formula for a triangular prism. You've got to find the area of all the faces. So the first thing I'm going to try to do is draw this net. And it's kind of tricky to do this, but remind me what I said. I said I'm always going to start with the bottom. So I'm going to picture the bottom of this triangular prism, and notice that the shape of this bottom is actually a rectangle that is 12 by 6. That's a 12 by 6 rectangle. From here, you got to think about how you would build a triangular prism. Well, the next thing I might notice are the front and the back. These are those triangles that make it a triangular prism. So I'm going to label those triangular prisms, and I'm going to label those triangles. I'm going to draw those down here, and notice how I have to draw that for this to fold back up and be what it should be. This is still 6, like we've talked about. Another dimension that I see here that's pretty important is that height of 4. I have one triangle there, and I have one triangle on the opposite side. Okay, now the question is, what else do I have? And I want you to notice that I have not one, but 2 faces left for this triangular prism. And you'll notice they look like rectangles that are on the sides that help build the triangular prism. So I'm going to draw 2 more rectangles on either side. And I already know one of the dimensions. We said this dimension is 12, right? So we know that this is 12 long. But the question becomes, what is this dimension here? When I'm trying to figure out how big this rectangle is, it's 12 by what? And what I would ask that you do is go back to this and just look at this this rectangle right in front. As I'm looking at this rectangle right here, I need the dimensions of this rectangle. Well, I see that it's a 12 by something. I need this distance right here. And if I'm looking for that distance right here, it looks like I might have to look over here and notice, oh, it's not 4. It's actually 5. This is a 12 by 5 rectangle. That's pretty important that I get the right dimensions down if I want to find the right surface area. Now I go about actually doing my business. Okay, well, I got to find the area of the bottom. Well, that's 12 times 6. That gives me 72 meters squared. The triangles that we know, it's base times height divided by 2, so 6 times 4. This should give me 12, and this should give me 12, right? I should have a total of 24 for my 2 triangles. And then lastly, we have the 2 rectangles that we just found, which were 5 by 12. I need to take 12 times 5. I happen to know that 12 times 5 is 60. So I have 72, I have 60, I have 60, I have 12, I have 12. What do I have to do with all these faces? Well, remember we said it's the sum of the area of all its faces, and the surface area of the solid is equal to the area of its net. So I need to find this total area. So maybe I'll do 12 plus 12, which is 24, and I'll do 60 plus 60, which is 120, and then I still need to add my 72. I'm adding all the sides. I did 12 and 12 was 24, 60 and 60 is 120, and then I have 72. And I go to add this, and I know 4 plus 2 is 6. 2 plus 2 is 4, plus 7 is 11, and I carry that, and I have 216. Question is 216 what? Well, it was surface area, so I'm going to say 216 meters squared. So, 2 things that are important in your notes so far is the concept of finding surface area by drawing a net, because there is nothing wrong with going through that strategy of unfold the solid, unwrap the solid, flatten it out, find the area of each of those faces and add them up. The other thing that we have given you is one formula, which you can use if you'd like, to find the surface area of a rectangular prism. And like we just said, there is no formula for the surface area of a triangular prism. But that brings us to our last shape, the cylinder. I want you to think about how you would draw a net for the cylinder, and it's kind of a goofy shape with circles and this other face around it. But so what we've said in the past is we're going to start with the bottom. So we're going to start with the bottom, which I think we all understand is a circle. And I think we all understand that there's a top that's also a circle, right? So I have a bottom and I have a top, and I've got to try to figure out how I can put these two things together. I've got the bottom and the top, and these two circles should be the same. In fact, maybe what I'll do to make sure we understand that these two circles are the same, we'll actually get that same exact circle and we'll put it down here. Now the question becomes, what's that other face? What I want you to picture with a cylinder, and there's some solids right there that we could look at in class, but I want you to think about how we would unwrap a cylinder. And what I really picture is like a soup can where I peel back the label. And if I peel this all the way across, interestingly enough, the shape, this face on the side of a cylinder, is actually very clearly a rectangle. The side of a cylinder is actually a rectangle. Right, so I want you to notice how this works when I draw a net for a cylinder. This actually is going to lead to something that will help us find the surface area of a cylinder every time without having to draw a net. Remember, surface area is the sum of the area of its faces. It's the sum of the area of its faces. So let's think about how we could find the area of these faces. Now, two of them are pretty straightforward. The circles. I think we know how to find the area of a circle. If you need to look back in your notes or in your examples, you can find it. But the area of a circle is pi r squared. That's true for that circle, and it's true for that circle. So notice if I tried to add those together, I'd have pi r squared, and I'd have pi r squared, or I'd maybe have 2 pi r squared. Right, those are the two circles involved in my surface area. But now I've got to figure out this rectangle. Well, the nice thing about this rectangle is we do always know what dimension I have right here. If it's the circle and the circle, this dimension in between them, this dimension right here, is always the height. Right, so I know I'm going to involve the height somehow. But the question is, how am I going to find this distance? How am I going to find this distance across the rectangle? Well, that goes back to what we talked about unwrapping the solid, and of course now wrapping it back up. If I went to put this rectangle around the solid, to put it back together, I want you to think what happens. This side right here, as I put this back together, actually has to wrap around this circle perfectly. At the same time, this side down here has to wrap around this circle perfectly. So this distance across on this rectangle, has to be a very specific dimension as it relates to the circle. It has to fit perfectly around the outside of the circle. Well, perfectly around the outside, that sounds a lot to me like perimeter, or in the case of a circle, we don't call it perimeter, but we call it circumference. So this distance across the rectangle is the same thing as the circumference of the circle. Now, we actually said there were two formulas for the circumference of the circle, and we talked about these last week. I can take pi times diameter, we said that gave us circumference, or we can take 2 times pi times the radius. And if you will recall last week, I said, you might want to start thinking about this one because typically we aren't given the diameter, we're given the radius. Well, here's where that example comes into play. Notice in the parts that we've already put together, we have r and we have r. Well, if we already are using r and we're already using radius, let's keep using radius for this dimension right here. So how long does that have to be? Well, it has to actually be 2 pi r. It has to be the circumference of the circle. So then the question becomes, well, now how would I find the area of this rectangle? Well, I would take base times height, or length, times width, or 2 pi r times h. 2 pi r times h, which leads us to a very important and valuable situation here, where I have the area of the circles, and I have the area of the face on the side, and I now have the formula for the surface area of a cylinder. So pretty important in your notes that you want to make sure that you have jotted down. The surface area of a cylinder is 2 pi r squared plus 2 pi r h. Like we just talked about on the last slide, that's because I now have the area of the two circles, and I have the area of the face on the side, that's the rectangle. And so if I can just have the r and the h every time, if I have the radius and the height, I can find the surface area. So one question we'll do together on surface area of cylinders, it says this soup can has a height of 4 inches and a radius of 2 inches. Find its surface area. Well, that tells me everything I need to know right there, guys. It has a height of 4 inches and it has a radius of 2 inches. Well, that's what I said I needed for surface area. I need height and I need radius. So remind yourselves, surface area of a cylinder is 2 pi r squared plus 2 pi r h. So as I go to do this, I need to start doing some substitution. I think we know that we'll put pi in as 3.14 as an approximation. So I have 2 times 3.14. And then it says r squared. Well, I go back up into the problem. It says the radius is 2. So I'm going to say 2 squared. Okay? Then I'm going to go over here, and I see 2 pi. And then it says RH, RH, RH. Well, R is 2, and H is 4. 2 pi r squared plus 2 pi RH. Lots of cleanup that we could do here. I have 2 squared, and then I have pi. Well, 2 squared is 4, and 4 times 2 is 8. This is 8 times 3.14. And then I'm going to still have this over here, 2 and 2 and 4. 2 times 2 is 4, 4 is 16. And then I have 16 times 3.14. I have 8 times 3.14 plus 16 times 3.14. Now, if you know anything about the distributive property and maybe even working backwards, this problem can become a lot easier. Now, I want you to hear what I'm saying. If you wanted to just do 8 times 3.14 and then 16 times 3.14, feel free to do so. That is totally okay, and that's up to you. But what I see is I see this common number. I see 3.14 and 3.14, and I'm going to take it times 8, and I'm going to take it times 16, and I see a plus in between. And so I think to save myself some decimal multiplication, instead of doing 3.14 times 8 and then 3.14 times 16 and then adding, I'm going to add the 8 and the 16 right now. And I'm going to say 8 plus 16 is 24. And I take 3.14 times 24, and that will help me get my answer. Now I'm saying it again. If you don't understand what I'm saying, go ahead and multiply like normal. Do 8 times 3.14 and do 16 times 3.14 and get your answer, and you're good to go. But because I can do it this way as well, I can maybe take this shortcut and do a little less decimal multiplication. 4 times 4 gives me 16, and I carry the 1. This makes a 5, and 3 times 4 is 12. I put a 0 here, then I have 8, 2, and 6, and I add them up. 6, 13, carry the 1 makes 5, and 7, 5. 2 decimal places in my factors means 2 in my answer, and I get an answer of 75 and 36 hundredths. And now remember, this is inches squared since we found surface area. Hopefully these notes help you. 2 main things to point out. Understand that you can always draw a net to find the surface area. Just think to unfold or flatten the solid. We did an example with a rectangular prism or a square prism there. We also did an example with a triangular prism, and we even technically did an example with a cylinder. But notice I also did give you 2 formulas. For a rectangular prism, the formula is simply 2 length times width plus 2 height times width plus 2 length times height. That's not as important as this formula right here for surface area of a cylinder. You're going to want to memorize 2 pi r squared plus 2 pi rh. Those are the notes.